The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. This is Anandan from Asia Leads Partnership. We will give few more minutes for people to join in, and thank you all for joining us today.
Here, when you're done talking, you have a.
I think we could start. So we have around 19 attendees. Um, Once again, warm welcome to all of you. May I request Cable to share your screen? I'll make the presentation from yours. Cable, can you hear me?
I can hear you. Can you see my screen?
Yes, great. Can you move on the slides? I'll just check if we can see your slide. Okay, great.
Can you see the agenda
Yes,
slide?
yes, Aj, I am seeing agenda slide. Thank you very much, Keval. So a warm welcome, everyone, and thank you for your patience and for joining us today. On behalf of Asia Leads Partnership, Leads Global Partnership, Transport Working Group, which is hosted by WRA, we welcome you all for the first virtual session of Mobility Communities of Practice. Before we move on to the slides, here are some housekeeping rules. So you will be in the mute mode initially. We will unmute you after getting through the first presentations. Um, so by then we want you to self-mute. that is the self mute option. You can see it at the top left hand side. You can use that option so that other people will not hear echoes, noises. At any point of time, please type in your questions at the bottom right hand side. We will continue, we will answer as much as possible during this session. If at all for any reasons we are not able to answer them during the session for lack of time, etc., we will continue to converse with you even after the session through emails and other modes. And in a while, we will also upload the presentation for today's session under handouts option. Right now, it's not there, but at the bottom, we will upload the presentation in a while. You can also use the chat option below if you have any technical difficulties in speaking or you want to know some options. You can at any point of time use the chat option and ask questions. And I'll now quickly run through the agenda for the day. I am myself Anandan. I work with Asia Leads Partnership, hosted by ICLEI South Asia. Our office is in Delhi. I support in managing Asia Leads Partnership Secretariat Services. I will give a little bit of introduction about this communities of practice and Asia Leads Partnership and Leads Partnership, the initiatives and um, the activities that are being carried out here. It will be followed by the presentation from Cabell, the expert we are having today. We will skip the introductions to the later end, and afterwards we will have presentations from Bhutan, Sri Lanka and Philippines. We already know the representatives, the country government representatives from Bhutan and Philippines are already here. So we anticipate Sri Lanka also to join, and after that we will have interaction session. We will discuss on the challenges what the countries are going to discuss. So we will have the open discussion also with the experts, and then we will conclude it with next steps. Could you please go on to next slide, please? Okay. The next one, Kabel. Okay, thank you. So, many of you may be aware of Asia Leads Partnership and Leads Global Partnership, but here is a very brief intro for people who have joined newly. Asia Leads Partnership is the regional platform under Leads Global Partnership. Leads Global Partnership, as you know, it's a global partnership that brings more than 300 organizations across government agencies, technical institutes, international agencies, and NGOs. It was founded in 2011. The main objective of Leads GB is to promote leads in the global arena through peer learning, technical cooperation, and information sharing. It operates through 4 regional platforms: Asia, Latin America, Africa, Europe, and Eurasia. And Asia is one of the regional platforms, one of the 4 regional platforms. Its main objective is to promote low emission development strategies in the Asia region. And all the works that are being carried out through Leads Global Partnership and the regional platforms are supported by 6 technical working groups like energy, finance, SNI, its subnational integration, benefits, transport, etc. About Asia Leads Partnership, it is a network of leads practitioners. It has a membership of more than 800 people, and 40 plus national government representation is there out of this 800 plus membership. We promote low emission development strategies in the region through coordination, collaboration, and partnerships. We do identify and share tools, resource materials, we conduct webinars, and through all of it, we raise awareness, we share success stories, and help to replicate projects in the region. We also connect national governments. If there is a need, we will connect it to experts, and thereby, with all these activities, we increase the capacity of leads practitioners and promote leads. For more information on Asia Leads Partnership and Leads GP, we encourage you to look into our website as well. And we also encourage you to become members of Asia Leads Partnership. Some of the features are specific to ALP members. For example, as part of Asia Leads Partnership services, we also offer remote technical assistances. So technical assistance to advance low emission development strategies in specific areas. So that is available for ALP members. So it is free of cost, and we encourage people to join. And next slide, please. Okay.
There's
For
a
the
slight delay.
uh, for this 2018, we have 4 communities of practice. Clean mobility is one of them. So previously, we also launched grid scale renewable energy. As part of it, we organized a couple of interactive sessions focusing on building blocks of energy planning, smart incentives, and enabling environment. As part of it, we also organized some events, deep dive workshops, as part of recently held ASF workshop. Um, so as part of it also, we enabled peer learning from each other. So whoever the COP members, the communities of practice members who are part of that grid integration were taken to this workshop. So that also enabled them to learn from other countries. It also helped ALP and partnership to go a step further and understand their requirements, etc. So this is the same way how this transport community of practice is also planned to be. For this year, the communities of practice will focuses on clean fuels in transportation. It looks into policy, technology, and regulatory framework, especially to promote public transportation. And coming to this mobility communities of practice, it is an interactive platform. We it brings practitioners. Um, okay, so we bring practitioners, experts, and national government representatives in one platform, which helps in learning and sharing from each other. This is a network envisaged to support COP members based on the needs of the countries that arises from time to time. Even the topic for the first session is selected based on expression of interest we received previously, and this network is member driven. Activities of also framed in such a way it supports um the need and priority of countries and the COP members. We want this momentum to carry forward even after the virtual session. We expect people to be in touch with other modes, like we are happy to explore other modes like LinkedIn, the other email chains, and other options to keep this interaction going on beyond this virtual session. Next slide, please. Okay, what does this COP offer to its members? So before going to that, I will just give a little bit of information about the type of members we have recruited so far. Um, Under this communities of practice, we now have around 42 members representing from 8 different countries, including Bangladesh, Bhutan, China, India, Malaysia, Philippines, etc., including South Korea and Vietnam. and people are coming from diverse backgrounds like government institutions, practitioners, experts, and this platform offers very good opportunity for people to learn from each other. So we want all to use this opportunity and learn and grow together. The current year's activities are also planned in such a way to achieve this objective of this peer learning. And some of the activities that we have planned are listed like similar to I was giving some example about this grid scale renewable energy practice activity. So similar to that, we also have interactive virtual sessions. Plus, we have a couple of peer learning workshops, and one of the workshops was organized recently in the month of May, a transport workshop organized by APEC and partners in Singapore. So initially, some early mover countries from these communities of practice were also selected to go over there and share and learn from them. We also arranged a site visit for them to go to Center for Livable Cities and explore the things being undertaken in Singapore. So similar such workshop will also be organized as part of this communities of practice down the line. And we also offer planning to offer deep dive support for a couple of countries. So this is the country specific assistance that would be provided to advance transport activities in a specific country. So early there will be a selection process and the early mover countries will be selected to receive this support. But there is this no cost technical assistance also available that is free of cost, and anyone under this communities of practice can also avail it. So we also encourage people to use this option. And as I was saying, this is beyond this virtual session also we envisage to continue this learning process. So thereby we also share the tools, resources, etc. to continue this learning process. Yeah. And before I introduce Kebal to take on this specific first webinar on mobility communities of practice is managed by ALP. Specialist Partnership leads Global Partnership hosted by NREL and Transport Working Group. And the first session focuses on public transportation and bus electrification. It also talks about the type of electric buses. Cabel will present on type of electric buses, key elements that are to be considered, some pilot cases, and the lessons learned elsewhere, plus some policy aspects to support bus electrification. And that's all we have here for the introduction. And uh, the, during after Cable's presentation, we will answer some 5 questions. Later on, in the later part of this presentation, we will answer rest of the questions. So we encourage people to type in your questions at any point of time. So yeah, over to you, Kebal.
Thank you very much, Anandan. It sounds like the LEDS Transportation Group has a lot to offer, and that was informative for me, and I hope it was for everybody else. Thanks to everybody else who is on the webinar this morning. It's evening here, but is the summer solstice, at least here. So the longest day of the year. So even though it's close to 9 o'clock at night, we still have a little bit of sunlight here at NREL. And we at NREL are tucked away in the mountains of Colorado in the middle of the United States. We've got a pretty large laboratory here with about 2,000 employees, 40 years of experience researching science and engineering. The original focus, as the name would suggest, is renewable energy, but we do a lot with integrated transportation systems. And we provide a lot of support directly for bus electrification, which is the topic of discussion tonight. We do a lot in terms of research and development. So a lot of that is on the battery technology side, trying to bring down those costs so that over time, the batteries that are offered by the OEMs can last even longer, cost even less, and the buses can be more in line with diesel prices. We also do things with powertrain development, thermal management, wiring, a lot on the technical side. We work directly with bus transit companies, both here in the United States and abroad. In fact, we're currently working with the Surat bus rapid transit system in India, and I'll talk about that a little bit further along in this presentation. And we do a couple of things there. So one is this third-party evaluation, where once a bus is on the road, we have an established evaluation protocol. And so we can look at it in terms of availability, maintenance costs, fuel costs per mile. And I can show you a couple examples of that later on in the presentation. We also do some of this sort of work in terms of supporting the low emission developing strategies groups, providing feedback to governments on the technical and the policy challenges as well. Before I came to NREL, I worked for the State Energy Office, where I developed policy to support electrification. It was mostly in the consumer market, but we are interested, obviously, in the public transportation market as well. And the last thing on this slide is the fleet assessments, and that's actually what we're doing right now in Surat. So it's an economic and operational assessment. They normally go hand in hand. Can the buses pencil out in the long term in terms of cost? And are they operationally feasible, or might you have to have a slightly different replacement ratio? Might you need 10 electric buses to serve the role that 9 diesel buses were previously serving? Do this in both the battery and the fuel cell electric bus markets. I'm focusing tonight on battery electric buses, but if fuel cell buses are of interest, we can certainly talk about that at a later point, or I'd be happy to answer some questions along those lines. This is an outline of the presentation. So 3 main areas. First is looking at the types of electric buses. So I'll talk about the fuel cell ones a little bit there. Planning considerations. So if you are a transit company or working with a transit company, municipal corporation, what do you
Muted.
Hello, can everybody hear me?
Yeah, everyone's saying.
Unmuted.
Yes, I can hear you, Abel.
I heard a message just at the end of that that said I was unmuted. So I think prior to that, maybe I was muted.
No, I think by mistake someone has muted you.
Okay.
Okay, yeah.
Do you want to go back to your outline?
So were folks able to hear me as I present the outline of the presentation?
Yes, now it's clear.
Okay.
Yeah, thank you.
All right. Well, so I'll just move on here to the fuel cell electric buses. One of the biggest pros of fuel cell electric buses is that you don't have any concerns about range. You don't need added buses to meet service. In many cases, they're more reliable than other buses. They do require modifications to the facility. Hydrogen is a gaseous fuel. It's under high pressure, and gaseous fuels rise, whereas diesel or gasoline liquid fuels are going to sink, and so maintenance facilities aren't necessarily designed for them. The hydrogen fueling station can be expensive, and the cost of the hydrogen fuel itself can be high. Now, those vary a lot, and one of the big drivers of those costs is the compression price. But there are opportunities in some cases to get waste hydrogen from a local refinery or some other sort of industrial process, in which case you might be able to get the hydrogen fuel much more affordably. Other pros include the depot logistics and parking being similar to conventional buses, and just that the fueling and operation are so similar. This is a bus pulling into a hydrogen fueling station, and as you can see in this picture, everything you see from the hydrogen fueling station looks about the same as a gasoline or diesel station. What you don't really see in this picture is that on the other side of that containment mole, there's going to be some high pressure compression equipment as well as some high pressure storage vessels. Depot charge battery electric buses, as distinguished from en route battery electric buses, can take advantage of off-peak charging rates. Talk a little bit more about utility rates on one of the following slides, but one situation that we commonly have here in the United States is time of use rates, where the price of electricity is significantly cheaper between the hours of, say, midnight and 6 a.m. when nobody else is using it. And so you might be able to get fuel for 5 cents a kilowatt hour instead of 15 cents a kilowatt hour, which obviously makes things a lot more affordable. You can centralize your charging equipment with depot charge buses, which allows for more flexibility on routes because you'll be returning to the depot every night regardless. The chargers here are standardized, and so you can get available, interchangeable, fungible chargers. And if you do need longer range on routes, you can add inductive chargers, so wireless pads along the routes to be able to provide some extra boost. And the charging in these cases is handled by the maintenance staff as opposed to the drivers, the bus operators themselves. In terms of cons, the larger onboard battery packs usually mean more expensive buses. It's important when you're buying depot charge battery electric buses to get only the battery pack that you need or will need over the next several years so that you don't pay a lot extra for that. You are going to need multiple chargers at a depot in order to support a large deployment. In many cases, you can share cords among the buses, but you'll then have to have somebody either move the buses or move the cords. This means you need to plan for logistics for operating the buses in the parking area, so it may change how your depot works. You may need to pay for electrical equipment upgrades, so new transformers and things like that. The charging time's often longer, and you might require a midday charge. All of this means that in some cases you will need more buses to meet the same service with a battery electric bus than you had with the previous bus. En-route charge battery electric buses are growing in popularity. They offer all-day operation with smaller battery packs, which means less of an incremental price over diesel. The depot logistics and parking are just like conventional buses, and a single fast charge station, although it might be expensive, can serve several different routes. For example, if you have a railway station or an airport that lots of buses are going to be running in between, you might be able to get away with one charger at each of those locations that charges the buses for 10 minutes, and then another bus comes in and charges there. The cost of the fast charger installation, though, can be expensive. You're often talking about something like 125 kilowatts. You see them as large as 500 kilowatts, which is a lot of electrical service. The routes can be limited by the charger location, especially if you don't plan in advance. And there's the potential to pay demand charges, so to pay for the maximum amount of time or the maximum charge that you are getting. A lot of utilities include a rate like that. Another con is that different manufacturers provide different types of chargers, and similarly to the bus depot charge electric buses, you may require more buses to meet service, although not necessarily. I wanted to show you some of the different options that are available just from one manufacturer as a sort of representative for the market at large. This is Proterra. It's a bus company here in the U.S., although they do sell internationally. I don't know if they sell in all of these countries, but they are trying to make a splash in China and some other places in Asia. So they offer depot and on-route charging. In just about every case, they can do overhead charging for the really fast power control systems, the 500 kilowatt ones that can give you, 20, 25 miles of range in 10 minutes. Those are going to be exclusively overhead systems. A lot of the other ones are available as just a plug-in pedestal dispenser, like you would see with a consumer electric vehicle charging station. To show you the range of zero-emission buses that are out there, and zero emission in this case refers to both fuel cell and battery electric buses. There are quite a few that are available in the U.S. There were some that we didn't show because they haven't sold a lot of buses, or they retrofit buses after the fact, which is also an option if you already have, especially if you have a relatively new bus and you want to replace it with an electric drive system and a battery. That is an option that's available. You see the battery sizes here just range tremendously. There's anything from this smaller BYD bus, which is actually the way they express it, the 90 kilowatt hour is 290 kilowatt hour battery packs, which is really 180, all up to 360. And then you see Proterra offers up to 660 kilowatt hours. They offer it. I don't know if they sold any systems that they get. They have sold some systems that are more in the range of 500 kilowatt hours. And in these cases, your range can vary quite a lot. Like this Nova bus here only gets 25 miles of range, but it can charge up those 25 miles in about 10 minutes. And so on a consistent route that only runs 15 or 20 miles, going with something like that, which is a little bit more affordable, might make more sense than a Proterra bus that has 400 miles of range, but you'll never need it. One of the options I didn't really talk about in here, but is offered is a swappable battery pack. And so in this case, you can have a maintenance technician, often a representative of the manufacturer, come in and swap out the battery packs along the route. They often talk about this as being a 2 or 3 minute process, so it can be really quite quick. It does seem to be pretty labor intensive, for what it's worth. Moving on to the next session here on planning considerations. We're focusing specifically on battery electric buses at this point. As I mentioned earlier, if we want to talk about fuel cell electric buses, we certainly can. The battery electric buses tend to be a little bit more affordable, offer some advantages, and seem to be more of interest to the group. So that's why we're focusing on them. One of the key things with battery electric buses is developing the specifications that will meet your operational requirements. And it's not always clear what your operational requirements are. It should consider things like how mountainous your terrain is. More than anything, though, it should consider the speed that you're driving. And the way we look at it is on a second-by-second basis, because that tells us how much stop and go traffic you have, which is actually good for battery electric buses because they can take advantage of regenerative braking and actually drive farther in cities in most cases than they can in the countryside. Based on that, you want to select a bus type that you think makes sense for you, as well as a charging strategy. So whether you want an on-route bus or a depot charge bus. And then using a modeling and simulation tool is very helpful. NREL uses trip recorders like the one shown in the bottom left. We have another one that reads a little bit more information off of your buses, but needs to be configured accordingly. So you can figure out things like air conditioning load or heating load. But these trip recorders are basic GPS recorders. And all they give us is the location of the vehicle, the speed, and the direction on a second-by-second basis. And using that and using a map like you see in the bottom right here in Kingston, Jamaica, we have a simulator. It's an Excel spreadsheet tool. It can also be used in Python. It's available for free on our website. Does take a little expertise to operate it, but you can model motor and battery needs using that tool. Infrastructure considerations are another big one. Depot bus placement of chargers, you're often going to run into space limitations as you put poles in your depots that might already be crammed. So you might need to look at alternative locations or maybe some additional footprint. Really depends on your particular situation. One charger can serve multiple buses. One idea that's pretty popular is to move the cord instead of the bus. So if you can get a longer cord charging station and line up another bus on the other side of this one, so to the left of this bus you're looking at here, another one to the right of the charger, another one to the right of that, you could have a single set of cords serving 4 different buses. Of course, if time and range and the speed of charging allow. So you need to consider all of that and the logistics for moving the buses through the property, especially if you are going to be moving the buses as opposed to the chargers in the middle of the night. I mentioned the transformer upgrades. Distribution and service panels will often need to be upgraded as well. Trenches, conduit, conductors. You can see here on the bottom left is access for permanent trenching. Sometimes when you are starting one of these deployments, it's good to start small, but to think about things in terms of the long term. So if you have 200 buses, you probably don't want to go 200 buses all electric all at once, but you might want to start with 5 with the knowledge that you'll be expanding to 50 or 100 in the next few years. And in a case like this, it's a good idea to trench all of your space at once to develop your charging strategy. You don't necessarily need to lay the wires, but if you're going to be making those initial investments in electrical infrastructure and those initial trenches and bringing that heavy equipment into your depot, you might want to stub up or allow for some holes where you can pull wire later and install more charging equipment. So it's a way to prepare yourself for that long-term deployment without laying out all of the cash at once. You will save yourself some money over the long term. Power cost considerations can often make or break an electric bus project in terms of the financial feasibility. There are normally a few different rates or a few different pieces of a utility tariff. And if you don't typically work with utilities, you might not know this. For those of you who do, sorry if this is a repeat for you. In commercial installations, there's typically some sort of monthly fixed cost. So some dollar amount that you're going to pay every month, no matter whether you use a lot of electricity or a little bit. You also pay the energy consumption rates. I've never seen a bill that doesn't have an energy consumption rate. So a per kilowatt hour rate might be something like 5, 10, 15 cents a kilowatt hour. Then there is often, but not always, and as I understand, it's country dependent, it's utility dependent, it's customer dependent in some cases, a peak demand charge. And that is a charge for the most electricity that you use in any 15-minute period during the month. The best analogy that I've heard for a demand charge is to imagine a canal with water flowing through it, and that's your electricity, and the high water mark in your canal for the month, that is your peak demand. Time of use rates mean that sometimes you'll pay less between midnight and 6 a.m. than you'll pay at other times. Sometimes there are super peak rates for, between 5 p.m. and 7 p.m. when everybody's coming home from work and turning on their lights. And sometimes there are different rates in the summer versus the winter. So having a pretty good understanding of your utility bills is really helpful. And typically what I like to do is just look at the last 12 utility bills, so the last 12 months, so you can see if there's any seasonal variation or if there are any weird electricity demand issues that are going on that might make sense for you to charge at a certain hour that's different than what you might have otherwise done. In terms of basic operational considerations, there are labor requirements. Maintenance is something you may want to work with the manufacturer on, but typically there will be some different maintenance requirements for an electric bus than there are for an existing diesel or compressed natural gas bus. And sometimes they're less and sometimes they're more. At least here in the U.S., our diesel buses all have particulate matter filters on them, and the particulate filters can clog up if they're being used in city driving, and they don't get hot enough essentially to burn up the particulate matter, and so they will clog up, and you'll often end up paying a lot for maintenance on the diesel buses because of that issue. Optimizing operation. Obviously, considering charging needs, we've talked about that a lot, but downtime and bus schedules are a really important factor as well, and whether you do in fact require extra buses if you're going to go electric, and how to minimize that. So just all of that pre-planning up front can go a long way. Training is important, and then one thing that we saw in some of the responses, I believe it was Sri Lanka, that the grid was not necessarily reliable 24/7. There may be seasonal issues with it. And in a case like that, you might want to consider something like on-site solar generation. In some cases, that can be a pretty affordable solution by comparison. Or you might just want to use, just have a backup diesel generator on hand just in case it goes down. One thing I think a lot of people think about power outages with electric buses, and it makes sense, there's a lot of electricity that goes into them, but if a power outage hits a diesel station or a gas station and they are pumping fuel out of the ground, they're going to have the same issue where the fuel does not operate, or the fueling dispensers do not operate without electricity. So this is not an issue that's unique to electric buses. It's an issue with compressed natural gas buses. It's something that you can't really get around in the bus world, but it's certainly worth considering either way. In terms of maintenance considerations, warranties are a really good way to get around some of the extra maintenance or the different maintenance that may be associated with it. If you are planning to buy a lot of buses, you can sometimes negotiate with the manufacturers to get a good deal, or to get an on-site bus manufacturer staff member who can handle the repairs for the advanced systems and train the bus depot staff. So maybe the transit staff will handle the preventative maintenance and the OEMs will handle any major issues. And if you have those buses under warranty, sometimes replace the battery packs if there's an issue. Training is really a part of that process. Normally at some point along the line, there will be a handoff from the OEM or the original equipment manufacturer to the bus depot staff. And training on the high voltage electric systems is important. All vehicles now have high voltage electric systems as part of them, but the traction buses are really a different animal, or sorry, the traction batteries are really a different animal. You may need special tools. You may want to develop a parts list in collaboration with your manufacturer so that you know what you should have on hand should you need it. So let's talk a little bit about some real-world battery electric bus deployments which we've been involved here. First one is the Foothill Transit Bus Company in California. They put 14 battery electric buses into service in April of 2014. So now we've got about 4 years worth of data on these buses. And interestingly, we're comparing them to compressed natural gas buses, which may not be the standard in most places. They're fairly popular here in the United States, but diesel is definitely the standard. And our next example, we'll take a look at that. These buses are using an on-route fast charge solution. You can see some of their specifications here. Got a 220 kilowatt motor, lithium titanate battery, and 88 kilowatt hours of range on the 35 footers and 106 kilowatt hours on the 40 footers. Now in terms of bus availability, those CNG buses running at 97% is really a pretty impressive number. It's not something that you typically see. Diesel buses tend to operate more in terms of 80–90%, at least here for the most part. But you do see the battery electric buses are not operating quite as much. There is more maintenance, and there are going to be some learning experiences as you convert to a new technology, really whatever it is. This looks at the maintenance costs and actually compares them. One of the big issues for Foothill was actually the low voltage batteries, so the starter batteries were problematic, and the manufacturer kept having an issue with the low voltage batteries, ended up replacing them with somebody else from a completely different parts supplier, and after that the maintenance costs were fairly in line between the battery electric buses and the compressed natural gas ones. In terms of fuel economy, the battery electric buses blew the CNG ones out of the water. Their average mile per diesel gallon equivalent, that's what that MPDG is, was about 17 as opposed to 4.3 for the CNG buses. And that's really the big advantage of battery electric buses. It's not necessarily that electricity is cheaper, which is sort of how it's typically seen. It's that you don't need as much electricity because the buses are so much more efficient. A few lessons learned from this project. Infrastructure is key. They didn't go in with a comprehensive charging strategy, not necessarily thinking they needed it for 14 buses. I would say for any case, you need a comprehensive charging strategy going in. Some of those things we talked about earlier, planning for scale, working closely with the utility as well as the manufacturers is going to put you ahead of the game. These buses dock, and I was looking for a picture of this but couldn't find it. So they dock, basically the driver is looking at a screen on the front of the bus that matches up underneath some high voltage lines, and the bus essentially slides in there, kind of like you'd be driving into a car wash. So you need to line up there, and then you sit underneath the high voltage lines and charge accordingly. They had a lot of driver turnover, and so for each driver, they needed to complete some additional training. There were some maintenance costs when the warranty period ended, and in that case, it's mostly on the low voltage battery, but it can be certainly with the high voltage systems as well. King County is the metro area that includes Seattle, Washington, up in the Pacific Northwest of the United States. These buses went into service in 2016. In this case, they were similar buses to what we saw in the last example, slightly larger batteries, only 3 of them, but also 40-foot buses. And they were, in this case, compared to some regular diesel buses, some diesel hybrid buses, so that use a smaller battery, take advantage of regenerative braking to some extent, and then a trolley system, which you can see at the bottom of your screen there. The fuel economy for the battery electric buses, again, was much better. However, those hybrid buses were doing a little bit better than the diesel ones, and the trolley fleet was using electricity as well, sort of similar to the battery electric bus. And so it's kind of a different way of looking at it. The limitation, obviously, with the trolley fleet is it needs to be connected to the electricity at all times. So it might work in a bus rapid transit type system where you have a dedicated lane, but doesn't necessarily cover your entire city. The biggest issue they ran into in this deployment was the expensive cost of electricity. They were paying 20 cents per kilowatt hour in comparison to the very cheap cost of diesel they were paying. So $1.60 a gallon, did the math on this before, but is about $6 or $6.50 per liter. It's about 40 cents a liter. That's what I meant to say. So at about 40 cents a liter, it can be difficult to compete with the low price of diesel, especially when you are paying twice as much as you would ordinarily pay for electricity. And that was in part due to the demand charges that they were incurring there in Seattle, which otherwise has pretty affordable electricity. They have a lot of hydropower. Again, I think that's similar to Sri Lanka there, which can be a lot more affordable than some other forms of electricity generation, like coal or natural gas. The maintenance cost per mile by system was a lot cheaper on the battery electric bus side than the diesel and then the trolley. The hybrid buses were pretty cheap as well, but the significant maintenance savings almost made up for the difference in fuel costs for the King County Metro system. And so you can see the maintenance cost for these battery electric buses is just about the same as what Foothill Transit was paying, but Foothill Transit was using some CNG buses that had very low maintenance costs, and so that's obviously going to be a big factor in the economics. It's not just about the fuel prices, it's also about maintenance. Lessons learned, charger availability. The scheduling of the routes was not necessarily timed perfectly in advance to take advantage of the on-route fast charger, and therefore they ran into issues where the buses were stacking up basically and waiting to use the fast charger. Operator training was part of that. Returning the buses to the terminal in some cases. People weren't returning the buses with a full charge. Operation planning. The bus range can limit the selection of routes, so it's something to think about in advance, especially if you're relying on a single on-route fast charger for several buses. And one of the issues limiting their functional time was just a lack of parts. It was only a few buses in this case, and they did not necessarily have the parts on hand to maintain them when they needed them. When you get into a larger bus fleet, it just becomes more important. Currently, we actually have a couple of analysts standing in the middle of that picture on the bottom left, Matt Jeffers and Jal Desai, who are in Surat, India. Jal actually texted me just before this presentation to say they were moving these trip loggers shown in the middle screen, and he sent me over these pictures as well so that we could put them in the presentation here for you all. Surat is in a good position as far as the data that they're currently collecting from their buses. The buses are Wi-Fi enabled. They're sending data to this smart transportation center that you see on the bottom right. And that's providing information not only on the speed of the buses and the fuel economy and mileage, but also how many people are getting on and off the buses in any given day, how much money they're collecting. They have video in this case. It's really a great situation that they're working with there. And I think the deployment of electric buses will really add a lot to their city in terms of making their bus infrastructure as smart as their back end is. The primary focus in this case is the Bus Rapid Transit System, or BRTS. They also have some city buses that aren't running fixed routes. We're tracking some of those as well to see if they're going to be good candidates. But I really like the Bus Rapid Transit System, especially in places where you have issues with traffic in the regular lanes. It can make these buses a lot more appealing to people than buying their own personally owned vehicle. The timetables are very consistent for these. And I think those things are going to make it a lot easier to determine which buses make sense and to overcome some of those lessons learned that we saw in the deployment in Foothill Transit as well as King County. So I know one of the focuses of this meeting is the policy, is really how to get things off the ground. And when I worked at the energy office, I like to think about policy challenges, I guess I still do, in terms of barriers to adoption. And I see four main barriers to adoption here. One is that the initial cost of a battery electric bus is higher than diesel buses. Second is the charging infrastructure. So the cost of installing it, as well as the planning necessary to do it in the most cost-effective way. The peak demand charges, how to take advantage of cheap electricity and not get caught with expensive electricity. And then just the staff familiarity with the technology. I pulled this table from the California Air Resource Board. And you can see here in the United States, these are the prices of buses across the board. They may not be completely reflective of the prices in other countries, I understand that, but I think it provides a pretty good reference point. So here a diesel bus costs about $500,000. You can see those prices are going up over time, whereas the battery electric buses cost about $750,000 in 2017 for the depot charge version, and about $730,000 for the on-route charge with the smaller battery. And those are falling over time. So you can see they're heading in the direction of price parity or at least price proximity. Fuel cell electric buses are still a little bit more expensive, $1.1 million in 2017. I believe, based on the date this was posted, that the 2018 numbers were projections, and so they may not involve a full year's worth of data. But upfront subsidies in either case can really help ease the burden of making this transition, especially for the first few buses, as you try to determine whether the operational fuel cost and maintenance savings will make up for the increased expenditure on the front end, or just whether it makes sense based on an emission strategy that your city has, trying to reduce diesel fumes locally or trying to reduce greenhouse gases globally. $150,000 or thereabouts seems to be a pretty common incentive level per bus. You see that in India, you see it in some Chinese cities, you see that in California. California offers up to $175,000, but that's for articulated buses, which are pretty large. They go, I think, as low as $125,000 for something more like a 30-foot bus. One other option, if an upfront subsidy is not feasible, is to look into leasing arrangements with the manufacturer. So between leasing arrangements and warranties, you can save a lot working with a bus manufacturer by not having to pay that initial cost over time. And if you have electricity fuel and maintenance savings, you might be able to balance out those lease costs or those finance costs over time. In terms of charging strategy, you're going to want to develop the most cost-effective charging strategy that can meet your needs. I really went into this quite a bit in detail in one of the earlier slides. This isn't so much a policy barrier, it's really a technical barrier. One thing I didn't mention on the earlier slide, though, was charging management solutions. So there is now equipment available in the consumer market that I am sure is coming to the bus market, which allows you to essentially share electrical load. So if you have a transformer connected to a distribution panel that's limited to, let's just say for the sake of argument, 400 amps at 240 volts, and you have 10 buses, each of which can charge at 100 amps. You might be able to plug them all in at once to charge simultaneously, but rather than each of those buses getting the full 100 amps, they might only get 40 amps worth of power at a given time. Or you can set up an arrangement where the first 4 buses will charge. When they're done charging, the panel will automatically move over, basically charge the next buses in line. And there's a product available through Eaton that's actually in the panel. ChargePoint offers this for commercial car charging solutions, and I think you're going to see it a little bit more in the bus market moving forward. So definitely something that's worth looking into from a technical side. Feel free to ask me questions later about that if that was not completely clear. Peak demand charges, talked about this a little bit here. Bus power demand can cost up to 90%. That can be up to 90% of your total electricity costs in some cases. So you might be paying 40 cents a kilowatt hour and have 36 cents of that effectively being the demand charge that you're paying. This is especially true with low utilization chargers. So it's important to figure out how to maximize your charge per vehicle. Sorry, it's important to maximize your electricity per charger as opposed to charging everything all at once on a whole bunch of different chargers. It's another reason why a managed network solution can make sense. Sometimes you can work with your utilities and make this a policy issue. So here in the state of Colorado, Xcel Energy is, well, the government has essentially negotiated a deal with Xcel Energy to waive demand charges in some cases, or to reduce them, to provide some different rate tariffs. There are a whole bunch of different ways you can do this, but essentially you can make things more cost effective because the utilities are interested in having a big customer like this and in opening up a big market, and they might be able to figure out something that makes sense. The last thing I wanted to show on this slide is that bidirectional charging can be an effective solution, and this might be a little bit further out for most places and most bus companies. This is the idea of selling electricity back to the grid when the bus is connected to a charger but doesn't actually need the electricity. You can participate in frequency regulation markets where you give a little bit of electricity back to the grid at a given time just to balance out the grid, rather than necessarily serving as a kind of bulk storage need, but it's a way to maintain the nominal frequency of the grid and basically to ensure good power quality for other folks. The other thing that's key, and I think we've talked about this a lot, but it's just really important from a transit company perspective to remember to train staff, to develop a training plan before you deploy the buses so that you are ready to go. and to consider those warranty options that are available from manufacturers. The last slide I have here is an example of an extremely successful deployment in Shenzhen, China. They started small for them, with 277 buses in 2012, and have grown to 16,359 electric buses, 100% of their fleet, and this is a fleet that's over 3 times as large as the bus fleet in New York City, in only 6 years. Through this process, they report a 48% reduction in carbon dioxide equivalent due to the better efficiency of those buses. And some of the policies that they used were that $150,000 subsidy per bus. They leased the buses from the manufacturer to reduce the upfront costs, effectively financing the costs over the long term. They developed a coordinated charging strategy. In this case, they managed 1 charging port for every 3 buses, which obviously reduced the cost of the charging infrastructure. And they negotiate a lifetime warranty on traction batteries. So if anything ever happens to any of the batteries on any of the buses, it certainly will when you're dealing with 16,000 buses, they can get a brand new battery from their manufacturer. So that's all I have in terms of slides. Hope it didn't get too technical towards the end there, but feel free to ask me questions. I know we have a couple of presentations coming up from some of our participants, Philippines, Sri Lanka, and Bhutan, and so I'm looking forward to hearing from them. If there are any questions you don't have the opportunity to ask now, my email address is listed up top here, as well as a couple of our experts on staff, Leslie Udy and Matt Jeffers.
Thank you very much, Cabell, for the great insight that you gave. And yeah, a lot of information and quite useful. So to begin with, some participants have already sent in their questions. So I will shoot out my first question to you. So just in case, like if someone is very new to this electrification, so where do they actually start? What should be the first step for someone who is the beginner?
So is this the question from the perspective of a transit company or a city municipal corporation, or is this the perspective of a country or a policymaker?
Say for a country, like Bhutan, or be it a specific country where mm, the setup is not there. If someone wants to look into this bus electrification or electrification of transportation in general, so where should they start with? Maybe you can give an example for a country.
Sure. So I think there are 2 key pieces for a country, a policymaker that's considering going down the route of electric buses. And I think the first thing is to have somebody in your country learn as much as possible about bus electrification deployment, about policies that are available in other countries. You know, I think a forum like this is a good opportunity to get started, but I think actually talking to some of the other cities to track down Shenzhen, or to talk to folks WRI, or to ourselves offline about some of these projects or some of these successful deployments is really important, and to understanding the technical capacity of those buses, what they can do, what's available in your country. One option for that is to put out a request for information from bus manufacturers, get an idea of what the market is there, so what bus manufacturers would be willing to sell a bus for there, what capabilities they'd be willing to offer, whether they'd be willing to lease buses in your area or send manufacturing. So I think that's probably the very first step. I think the second piece and it probably goes hand in hand before you manage much in the way of successful deployment, is setting up a policy from a high level. And so understanding what your goals are. Are you trying to test out the technology to see if it works, to get some information? In that case, maybe a pilot project is the way to go. Or are you trying to really affect some sort of large-scale changeover? And in that case, what's your motivation? Is it emissions? In which case, maybe you want to just open it up to all zero emission buses, or you want to incentivize buses based on how clean they are, like a scale of how clean they are. Or in the case of India, I think one of the motivations there is to develop the buses themselves. So they provide incentives only if the buses are produced, at least to some extent, in India. So I think they start with 15% localization, and they go up from there. So the extent to which that is sourced there can be an economic driver. So understanding some of those fundamental questions as far as what you're trying to do, and then developing policies that directly support that. I mean, I don't think there's anything wrong with the government saying we want to support these buses to the extent they're made here, or we want to support buses that are clean and reduce emissions, or we just are more concerned than anything with having reliable transportation. I think these are all important policy drivers, and figuring out what the primary one is, or the primary few are, can really help give you direction as a country.
Great, that is helpful, Kebal. I think people will also have additional questions in continuation to that, but yeah, I'll move on to considering the interest of time, the next question. Are there any studies to show the financial incentives work better to promote the electrification? It could be at any level, but is there any cases?
Yes. So I actually have not, and I was looking for something in preparation for this discussion specific to electric buses. I think it's so new that there's not a lot of analysis about what's worked so far. But in the U.S., one of the sort of nice things about analyzing policy here is we have 50 different states, 4 additional territories, each of which has its own set of incentives, in some cases its own set of requirements, all sorts of different subsidies, access to HOV lanes. So in the consumer electric vehicle market, right, so mostly passenger vehicles in this case, there's a lot of analysis on this. And a colleague of mine, Kelly Johnson, is publishing a paper. It's not out yet, but hopefully it will be published in the journal in the next couple months, at which point we'd be able to share it. And buried in the appendix there is an analysis they did of the effectiveness of subsidies, different types of subsidies in all 50 states here, and any territories that included them. And they found a couple interesting things. One, the incentives appeared to be more effective for battery electric vehicles than for plug-in hybrid electric vehicles. They did motivate people to purchase the electric vehicles. At least there was a correlation there, right? States with higher incentives had higher adoption rates of EVs. They looked at it in terms of time, so they looked at when an incentive was enacted and what changed in the following year, and based on that analysis, they saw a change there. Another thing they found was that rebates at the point of sale were more effective than tax credits that people had to file for later. And it just makes sense. I mean, if you only consider the time value of money, that would make sense. But it's more than that. It's if a rebate is easy to get and you can take advantage of that. I mean, if you can roll a rebate into your financing, you may be able to afford a vehicle, whether it's a car or a bus, that you wouldn't be able to afford if it's just a year from now. You're going to get some money back based on that purchase. So I think both of those were pretty interesting findings. There's some more literature out there about that, but would be happy to share that once the article is published.
Thank you, Keppel. I think that will help people to understand how it's working in other countries, and maybe it's a good case study for others to learn also. And one basic question, like people have asked, what is the for any beginner? I guess this will be a question. So, what is the major difference between the maintenance and asset management between the conventional buses, diesel buses, and the electric buses? So, yeah.
So long term, the battery electric buses have fewer moving parts, and so we would expect them to have lower maintenance costs. But they have completely different systems. They don't use a diesel engine. There's no compression ignition, or like with the CNG, there's no spark ignition. So their engines don't look anything like a diesel engine. And that, although long term, it certainly could be an advantage, means that they're unfamiliar to maintenance staff. And so in some cases, might make sense, especially if it's, the first deployment in the country, to go to another city, to go to another place, where the bus folks are more familiar. Work with some of the staff there. There are exchange programs like that. Manufacturers often offer them as well. And then, of course, the batteries. So the battery cells sometimes fail, sometimes need to be replaced. And in that case, that's typically something that you want to put onto the manufacturer again, but it could cost money there. So the systems look different. The cost long term should be cheaper for electric buses. And in some cases, we've seen that. But in other cases, just the newness of the buses is going to make them cost a little bit more money.
Okay, yeah. I think it's the practical difficulty people will have for the switchover. And one final question, Keppel. What is the um, environmental benefit of fuel cell buses in comparison with electric buses?
So it can be just about the same. So fuel cells, hydrogen fuel cells, which is really what we're talking about here, normally get their power from either electricity or natural gas reformation. So it depends on the source of that. So whether you are using electricity and converting it through an electrolyzer into hydrogen, or if you are reforming natural gas, that's going to really make the difference on the hydrogen side as far as the environmental benefits. You can use completely renewable energy. We actually have a hydrogen fueling station at the lab at our wind site where all of the power comes from wind turbines, and in that case, it's zero emission. You would see the same thing with an electric vehicle if you were pulling all of your electricity. Electric buses, their environmental advantages are going to depend a lot on what sort of power you're using. If it's hydropower, won't have as much in terms of greenhouse gas emissions. I understand there are other concerns that aren't necessarily captured in that metric, but wind, solar, you can get, an effectively weld-to-wheels zero-emission bus. Even with coal or natural gas, in both cases, you are getting a much more efficient bus. So 3-4 times more efficient than a diesel bus. So even if the source is the same, you might be able to reduce emissions fairly significantly. But I guess the upshot is that it really depends on your source of fuel. So your upstream source of fuel, whether that's your electricity generation or for hydrogen bus, whether you're using natural gas reformation or electrolysis.
Okay, great. I think there is one question from Bhutan as well.
Does it matter?
Yes, so I can read it here. It looks like, could you compare the effectiveness and efficiency of electric buses
Yeah.
with respect to plain and hilly roads? This is an interesting one because there are actually a couple things going on in hilly terrain. Often they're at higher elevation. Like here in Colorado, we have very hilly terrain. You could see the mountains in the background, that picture of the lab. And at higher elevation, electric buses don't lose any of their efficiency, whereas diesel or gasoline buses will. Any naturally aspirated engine, so something that's pulling in oxygen, if the oxygen is not as dense, you're going to lose efficiency. And it's a real problem here in Colorado. Turbocharging can help, basically, really compressing the air can help, but nothing compares to electric buses in that case because electric buses don't lose any efficiency. Going up hills, you are going to lose efficiency in either case, but electric buses actually have the advantage over diesel buses in hilly terrain, even if it's at sea level, because they can capture the power that's regenerated as you go downhill. So if I were to drive up to Vail Mountain from here, so up to a ski resort, I would not get as good of a range as I would driving around here locally. But as I came back from Vail, I could, in some cases, regain some of that range. I have a colleague who drives a Chevy Volt who tells me that coming to work, he actually adds miles to his tank or to his battery from all the regenerative braking he does coming down the hills.
Sure. Thank you, Kebal. The attendees also, participants have a few more questions, one also from Sendro. And considering the interest of time, we will move on. We have a couple of country presentations as well. But definitely we will get back to all the questions later during the session or after that as well. Yeah. May I now invite Leki Choda from Bhutan. He is the planning officer in Road Safety and Transport Authority that comes under Ministry of Information and Communications. He'll present on initiatives that are being undertaken in Bhutan to promote electrification and also the challenges they face. And he'll talk about Bhutan country perspective. Mr. Leakey? Mr. Leakey, you're self-muted. Kindly unmute yourself.
Yeah, okay. Okay, thank you, Anandan. Hello, good morning all. Hello,
Yeah.
can everybody hear me?
Yes, people will be able to hear. The thing is, most of them are self-muted or muted, so they are not
Okay.
able to reply. Yeah.
Okay. Good morning once again. A very warm greetings from Bhutan. To introduce myself, I'm Liki Chodda, working as a planning officer under Road Safety and Transport Authority, who is the lead agency in taking care of all transport-related, surface transport-related matters in Bhutan. And we are working under the Ministry of Information and Communications, which have 5 departments under that. And for your kind information in the beginning itself, in Bhutan, we do not have Ministry of Transport as such, as a governance structure looking after the transport sector. To begin with, I would like to firstly offer my heartfelt gratitude and thanks to ALP Asia, Avantika and Mr. Anandan for inviting Bhutan to take part in this online session on the electrification of the buses, which is very important for Bhutan as a very environment-friendly country. To talk, I will be just sharing. I'm very sorry for all the attendees here. My slides here may look somewhat awkward because I didn't have that time to really focus on preparing my slide very good. So I had to rush up and send the slides to ALP Center there in New Delhi. Okay, Mr. Anand, next slide, please. Okay. Briefly talking about the initiative being taken by Bhutan to promote electrification of the buses. Currently, Bhutan recently started. It is from the year 2013 or 14 that Bhutan started this electric vehicle initiative, whereby till date we have just around 99 electric cars are registered with the authority flying around in Bhutan. But we are really facing the problem of having the very good charging stations for all the electric cars. So to quickly bring on the nature of the buses that ply around in our country, I must admit that we currently do not have any electric buses in Bhutan. Bhutan, looking into the economy of the country and as a developing country, I feel that we are not in the position to afford to buy or purchase electric buses in the country. Maximum of the buses, around 200 buses plying in the country from one district to another, and you might also be aware that our country is stretched, the areas of the districts in our country is stretched with far distance from each other, from one district to another district, and many of the buses, diesel buses, are plying between all those 20 districts that we have in our country. So one reason that we did not start with electric buses is because of the distance that we have to cover, and as you all know, we are 72% covered by the forest, green forest, and our routes connectivity to the 20 districts goes along all those forestry areas, and having to install all those electric buses charging stations is very difficult job for our country as a very small economy. However, in the absence of electric buses in the country, we are focusing on improving public transport system in our country through really looking forward to really encouraging through encouraging the private individuals to operate more buses, connecting every nook and corner of our country. But even then, also we are not in the position to really influence or encourage individual operator to purchase the bus and operate in any routes they like, because we have to look into the profitability of the routes they choose for, and also as a mountainous and hilly terrain of the country, there's every chances that the routes, nature of the routes, and the route engineering is not very good for all those heavy buses to ply around all the remote areas of our country. So therefore, beside all those challenges that the authority faces, we are definitely working on improving the public transport buses in the country. We are also looking into increasing the subsidy to the individual private operators of the buses. For your kind information here, in Bhutan, we are regulated. The buses, public transport buses in our country is a regulated market. The authority, like my agency, we look on fixing the fares and also regulating the driver's discipline. We also fix the sitting capacity of the buses, but the operation or choosing the routes totally depend on individual private operators who wishes to buy the buses, and the buses that ply currently are in our country is all diesel buses. We have around more than 200 buses plying in the country from one district to district. We have 20 districts, 205 local districts, which we usually call geogs, and all those we are trying to connect all those 205 places, remote places in the country. We are trying to connect with the public transport buses. Currently, we have connected around 143 local districts with all those buses, partially or fully connected with the buses. So that's why we are currently we do not have the electric buses in our country. Another plan that we are looking to promote the use of public transport is shifting from the use of private car as a mode of transportation. In the 12th 5-year plan, in the next 5-year plan, we are also looking into working collaboration with municipality, city municipal corporations in purchasing more city buses in order to shift the mode of transport from private cars to the public usage of public transport in the urban areas such as capital city and many developing urban areas where we face the traffic congestion. We have the electric vehicle initiative going on in the country. We are also trying to replace some of the taxis with electric cars, but the challenges that we have is mainly on the charging station, though Bhutan is very rich in hydropower. Ananda, please, can you change the slide? Okay. Just to cut brief, the challenges that we are facing, as I mentioned earlier, one is infeasibility because of the geographical nature and the hilly terrain of our country. Electricity, though our country is getting fully electrified, then putting or establishing charging stations in and around the country is very infeasible because the charging station require electricity, and being covered by the very dense forest connecting the places via the route, it is very difficult for us to establish the charging station. Therefore, the coming of the electric buses is not yet started in our country. Affordability, being a very small economy, Bhutan being a very small economic country, we really doubt about our capacity to afford to buy the electric buses. As Mr. Campbell mentioned, it is very expensive than the diesel buses in terms of the cost. Reliability, just now as we are on the process of the very initial growth of socio-economic development, we don't feel that in absence of charging stations, in absence of the proper planning and design of the routes, in absence of the proper governance structure, we could come up with the electric bus. We could afford to come up with electric buses so that the people shift to this. Because just now around more than 200 buses plying are all diesel buses, and all those diesel buses are opted by the operator. Unless the government takes their own initiative and on the foot to buy the electric buses and provide to the public as a service. So these are some of the infeasibility, affordability, and reliability is some sort of challenges that we have to really take into consideration before we really jump into electrification of the buses in our country, mainly because of the geographical terrain of our country, hilly road, the turn and rounds of our roads. Therefore, these are some of the challenges. Thank you. I look forward to hearing from other and as supported by ELP, let us work together for that. Thank you.
Thank you, Mr. Lekhi. Good afternoon, everyone. This is Avantika from ALP. I'm Anandan's colleague, and Mr. Lekhi, I would like to thank you on behalf of everybody for giving us such a nice presentation. And I would also like to mention, as you said, that you're taking initiatives to connect to public transport, to connect people to public transport instead of the private vehicles they're using. I think that's a great initiative for a country like Bhutan. And you've also mentioned that you're also facing financial issues to buy electric buses. But I would also say we already had a discussion on this, since we're already trying to connect people to public transport. So I would request Kabil to give you some insights on how can you, like you already you are already rich in hydropower, whereas we have countries which are facing charging issues, infrastructure issues, charging infrastructure issues. So why not we should come up with some kind of policies or strategies to utilize the potential of the country which is already existing. So I would request Keval, if you can just give some feedback to Mr. Lekhi on how well they can prepare policies or strategies, how as a part of ALP, how we can, from this forum, how we can help them to take up some better policies and maybe rules to implement electric buses in the country.
Absolutely. Thank you, Avantika, and thank you, Mr. Leakey. I appreciate your presentation to provide a lot of insight into what challenges you're facing. And it sounded to me, correct me if I'm wrong, but like the primary challenge was the geography in Bhutan. So it sounds like you have, a lot of distant traveling. And understand, and I think in that case, there are two things that I think of. And the first one is understanding or having that data to be able to calculate where exactly your buses are driving, how many miles they are doing in a given trip, and understanding really whether this technology can make sense for you, or what size of batteries in a bus you would need. And in some cases, you might find that there's some low-hanging fruit out there. So some bus routes that might make sense, and then some other ones that might not. And you'd be able to pick the ones that are most cost-effective. So doing something like we talked about with the data loggers, and understanding on a second-by-second basis, really, how buses are operating. Another thing that I thought of, because you're talking about in the electric vehicle initiative more generally, is the charging infrastructure that you need. We do also have a tool for that, so that you can understand where you would need charging infrastructure and whether you need level 2 or fast chargers to support vehicles, to have them available, so that you'd be able to stop along the way and to charge. A couple other just kind of bigger picture ideas are to look at some of the policies in neighboring countries that might have had success, especially if they're in a similar situation, like a more rural situation. Whereas, I know a lot of the case studies so far are focused on cities, but understanding that rural situation, I think, could make a difference. In fact, it's something we've looked at here in Colorado. So there's a study I'd be happy to share on that looks at where to put charging infrastructure to service people that may live in the city of Denver, but travel up to the mountains on the weekends. So I think that maybe some of those things could be helpful for you.
Thank you.
And let me know if any of those really make sense for you.
Definitely.
Yeah, I think now we can move forward. We can move forward with the next presentation from our guest from Philippines. I would like to invite Ms. Joycey. She's a landscape architect representing Road Transport and Infrastructure Department of Transportation. Ms. Joycey, you would have to unmute yourself.
Hello.
Yeah, please carry on.
Hello. Hi, good afternoon. This is Joyce from the Department of Transportation of the Philippines. And my general presentation will cover electric vehicles and public transport in the Philippines in general. So, is the presentation already on? Hello. Yes.
Yeah, you can carry on now.
Okay. Um, so my presentation will be covering the current situation, the government efforts, and the success stories in the Philippines as of the moment. Next slide, please. So currently, the Philippines is on its nascent or early stages in the electrification of vehicles because of the issues or the concerns rather presented on the slide. So we have the vehicle standards and registration issues, infrastructure servicing, battery efficiency. Hello. Yes, battery efficiency, maintenance, and unit costs of funding and incentives. So, uh, the Philippines have so the infrastructure in the Philippines isn't ready, and some policies are still underway. So we are just preparing the country for the accommodation of electric vehicles, more so electric buses, and like aside from policies, infrastructure, the people and industry training are also just underway. Next slide, please. So at the moment, we have some policies like, for example, we have the Philippine Environmentally Sustainable Transport Strategy, which is a general framework for the sustainability on transport in the Philippines, and we have a few other policies by the Department of Transportation and its attached agencies, which is LTFRB, Land Transportation and Franchising Regulatory Board, and LTO, Land Transportation Office. And also we have a few House and Senate bills underway. I think there is at least five each from the House and the Senate for the electrification or the promotion of electrification of vehicles. But well, as you can see from the bottom left of the slides, the common theme mostly is for preference, priority, and fiscal incentives is still being written. So right now, all our policies and the present guidelines just suggest preference and priority, and incentives are really not yet on, fiscal incentives are really not yet on the table. Next slide, please. So, but with given the previous situation and the policies that were presented, we also have a few success stories. Like these two are the most prominent ones in the Philippines. Star 8, the Star 8 uh, jeepneys with regards to public utility vehicle modernization in the Philippines. And this is implemented in Tacloban City, uh, south of Manila. And this Green Frog bus system, which is a very significant bus system that runs from east to west of Metro Manila and passes through the two big business districts and then the university area in the Manila city. So at the moment, we, as said earlier, we're just on the earlier stage or early said stage in the electrification of vehicles in the Philippines, but these two are the most prominent examples that are already implemented. But underway, we also have these are already not on the slides, but the under the public utility vehicle modernization program, we have uh, we have updated the franchising guidelines to what vehicles or public transport vehicles will be given franchise, and these encourage, as also mentioned earlier, that they encourage the use of hybrid or hybrid Euro 4 and Euro 4 or better and electric vehicles. And this franchising guidelines applies to all the public transport system in the Philippines. And uh, yes, right now, the government has a lot of efforts from different sides, from the Senate, from the department, the national government agencies themselves, and even the private sector are joining forces to put the electric vehicles out on the streets. Yes, but as of the moment, we only have we were still in the preparation to put this put this matter on the successful implementation. So that's it. Thank you for inviting the Philippines in this webinar. That's very helpful for everyone. Thank you.
Thank you, Ms. Joycey, for your presentation. We would like to ask if you feel if there is any other aspect of electrification of buses which you, representative of your country, would like to take a deeper discussion into, and how would you like to see the support being delivered to you from our point of view?
Probably as of the moment, probably similar to the issue of Bhutan, where the probably the charging systems, because right now the bus system of Metro Manila is also being uh, rationalized. So we are improving the routes, and we're improving the number of vehicles needed in Metro Manila, and of course in other parts of the Philippines. And with this, I think one of the main issue would be the placement of the charging stations and uh, the maintenance, because I think that's one of the issues that may be raised, like the placement and how how the immediate environment may be affecting the the charging stations, not only, for example, weather protection, but also from the from its interaction with or the human contact with the charging stations.
Okay, thank you, Ms. Joycey. With this, I think like we've been listening to Kebal also, and also to the two countries which we've listened. It seems that charging infrastructure is a major problem which the countries are facing. And besides that, I also feel that at few places there is like when the government makes policies, there's very less budget, or sometimes it is not considered for research and development activities for R&D. So I would like to know from Kabul that how much do you think that how can the government incorporate such kind of things into the policies? Can you give us some insight on that, Kabul?
Sure, absolutely. I think you hit it on the head, and Joyce, it's helpful to hear your presentation. It sounds like from a policy perspective, you guys are really ahead of the game. Just seeing the sheer number of laws and policies that you had on the book, it sounds like you're really moving in the right direction as far as paving the way for electric vehicles and for the charging equipment. In terms of what you mentioned about rationalizing the routes and figuring out where to place charging equipment, similarly, I think I mentioned this already to Bhutan, but we have done analysis along those lines as far as figuring out where to put the charging equipment. There would be some expense, and so as Avantika kind of mentioned, I don't know exactly if it's an R&D budget but something along those lines in terms of research, and being able to do those. A lot of times, the country's energy office, that's the Department of Energy here, can get budget that's allocated towards something generally like bus electrification or towards just the electrification of vehicles, and you might be able to work with that. In some cases, you may find that some of your universities have some expertise in that. It's something that we found in India. The SVNIT, their Institute of Technology, has a location in Surat, and so we're working with a professor of electrical engineering on the charging strategy, and we're showing her how to operate some of the models, so that it's not just a one-time thing. NREL does some analysis, and that helps one bus company in Manila, but it doesn't help the rest of the Philippines. But really, that capacity building, and adding that into the government budget, to factor that in, I think that's really important on the front end, because you want to see your initial project succeed, or you want to at least put yourself in a position where you can learn a lot from them. And so having that analysis on the front end is going to make a difference. It's going to be able to help you baseline it, and see whether you're succeeding, and hopefully to succeed in the first place. So I hope that answers the question. Might have gotten a little bit off.
Yeah, thank you, Kabil. Thank you for your insights. We have few more questions from the audience. Okay, so first we'll start with Ms. Zahida Alam. We have a question from Ms. Zahida Alam. Can you please ask your question to the expert, please? Ms. Zahida, can you hear us? You had a question for the expert. Can you please ask your question?
I think Sahida has self-muted. You should unmute yourself. And if someone has a question, please raise your hand. There is this hand button that you can see. You should just click onto it, and we will unmute it from organizer end. So you will be able to ask questions to the expert.
Hello.
Yeah, hello.
Hello. Yes, Zahida speaking.
Yeah, Zahida.
Hello.
Please ask your
Yes,
question.
from Bangladesh. Yes. My question is, yes, I understand air conditioning through battery for buses in a challenge for hot and humid country. Any comments?
Yes. Sandita, was that? Yeah, so we are looking into that actually right now in India. So understanding what the air conditioning load is in a bus that has standing room only, you can actually track that, the auxiliary load on those buses, and there's some information that's available out there already in terms of what a typical air conditioning load adds to the bus and subtracts from the range. But having that exact information is really helpful. And basically, if we can track the auxiliary loads, which you can do through some type of vehicle telematics devices. We use these Isaac data loggers. Isaac is the brand of the company, and configure it to read the CAN bus, so the message protocol on the bus, and it can tell us exactly what the air conditioning load is. But that's going to be a factor for gasoline, diesel, electric buses, really any of it. So it certainly influences range. One way to approximate it, if you don't have that data available, is just to look at the fuel economy of the buses and compare that to the manufacturer's fuel economy, which here in the U.S. is basically based on driving on a flat road at with 70 degrees as the ambient air temperature. And so you can see kind of what losses you're suffering there. You might not know necessarily whether it's based on the air conditioning or not, but if you look at the fuel economy and you look at it also on a monthly basis, and so compare it the hot months to the winter months, you can come up with a pretty good approximation of how much efficiency you're losing.
Yeah. Thank you, Kabul. Now I would request all the participants if they can let us know what do they want to learn next from in the next session related to electricity, electrifying of the buses or public transport. So if you can give the suggestions on that.
Trial.
Hello.
More about, yes, more about electric vehicles.
Trial.
Yeah, we would request all the participants to let us
Trial.
know what is their priority and what do they feel like from how can this forum be more helpful to them.
Trial. Trial.
Is this Miss Bao? Please
Hi,
go ahead with
everyone.
the question.
Hi, everyone. My name is
Trial.
Sanjini, and I work with Kabel at NREL. So I'd like to reiterate the question
Trial.
that Avantika just asked, which is, in order to be able to help you with your priorities
Trial.
along the topic of electrification of buses, it would be a good thing for us to know what would be the next deep dive question that you would want to learn about. So this will help us in future planning of sessions. Today's session was an overview of all the factors that need to be taken into consideration in order to move the process forward. But of course, within that, as you heard, there are so many deep dive questions. Is it infrastructure? Is it capacity? Is it technology? Is it policy? And so for each of your countries, I would assume a unique challenge or solution needs to be available. And so if you have any ideas of what that is, feel free to express it at this time. Thank you.
I am Shah Zulfikar Haider from Bangladesh. The concept of electric vehicle is quite new in our country, though we understand that in order to save climate, we have to go for electric vehicles. And another challenge is that solar renewal is not that much feasible because of land constraint. My view is that if we can have electric vehicle charged through renewable sources, then it is more economical. Is there any comparison about cost between charging through fossil fuel system or charging through solar system? Thank you.
Yeah, Kabir, would you like to answer that question?
Sure. So here we have some information that's available in the U.S. on levelized cost of ownership of different generation sources. So, with solar or wind, there's an initial capital cost, but in a lot of cases, especially in a sunny country for solar or in a windy country for wind turbines, you can pay less for that generation than you might pay for thermal generation like coal or natural gas. It's going to depend on what resources you have available in your country and what your commodity costs are. But it's going to make a big difference. And so, one thing to take advantage of is economies of scale where you can. Normally larger installations are going to be more cost effective than just a rooftop generation system. But there are certainly some options out there, and I think what you need to do in that case is just figure out what the cheapest thing is, or maybe what the cheapest thing is within certain parameters. If you're only looking at zero emission generation, that's going to limit your options. But maybe if you're looking at all generation, you'll still find the zero emission generation is cheapest.
Does anybody else have any questions or suggestions for next peer learning experience or topic?
Since that Shazukar Heather again, since the technology is new for developing Asian countries, if we can have link of some YouTube or other practical demo, it may be helpful to understand more. Thank you.
Yeah, that's a good suggestion. We'll look into some other ways in which we can provide more tutorial type, more information. and provide to the whole group.
Suggestion that since India is very advanced and it has got a vast technological advantage and vast market also, so we can share their experience for those countries which are still new electric vehicle or other subjects. Thank you.
Yeah, and I think that's very essential because the entire program depends on peer learning experiences. So within our community of practice, we have a full gradient of countries depending on which level they're at in terms of this whole process. So the countries that have already figured out solutions, yes, we should help others overcome the challenges. And so I think that's an excellent way of learning and teaching others. Thank you for that suggestion. So I think, Anandan, we are probably towards the end of the session, and if there are no further questions or suggestions, I believe there's a survey option at the end of the webinar that people can answer in more detail.
Yes, when the webinar ends, people will have the option of taking part in the survey, and you're requested to please take a couple of more minutes to give us your feedback and the next topic, so that accordingly we will design our next session, and we will, as this is the learning exercise is members priority driven, we want your inputs to shape it better and make it beneficial for all. Avantika, you have any final remarks?
Yeah, I would just like to add one thing. We are also there on LinkedIn. We would request you all to participate in that. There's a page on LinkedIn called Community of Practice, Clean Mobility for Cities in Asia Pacific. So we can have a discussion on that. Whatever questions or whatever issues the countries are facing, you can all put your issues on that, and we can have a deep discussion over LinkedIn also. And besides that, we've tried to address most of the questions today. But in case if there are other questions, you can always write back to us, and they can be forwarded. We'll forward those questions to the expert, and we will definitely get back with solutions to you. And we would request you to stay in touch with us through emails. Kebal has already given his email in the presentation. There are two other experts also, Kebal, Leslie, and Matthew, with whom you can get in touch. But it would be better that if you get in touch with us, and we can forward your queries to them. And as already mentioned, there's a small survey. After this, we would like you to fill that survey. It will take just 2 to 3 minutes of you. And thank you very much all once again for joining. Thank you very much.